All right, welcome to part 1 of your ultimate NEC study guide. If you're gearing up for your electrical certification, you already know the deal. The National Electrical Code is the absolute definitive benchmark for electrical safety. In this explainer series, we're going to thoroughly decode the foundational rules and definitions you need to master, not just to confidently pass your exam, but to execute safely out there in the field. Okay, let's dive into this. We're going to be looking at how the code has aggressively evolved through the 2023 cycle right into the newly updated 2026 edition. We're cutting through all the fluff and focusing strictly on the high-yield rules you will be tested on, translating that dense code language into clear, actionable understanding.
Think of this as your syllabus for today's study session. We'll start with scope and arrangement, move on to mastering Article 100 basics, look at some modern code updates, and finish up with safety and spaces. Basically, we're moving logically from the rulebook's outer boundaries into a rapid-fire drill of definitions and wrapping it all up with real-world execution.
So before you go off trying to memorize every single rule, you really need to understand exactly what the NEC covers and, honestly, just as importantly for your exam, what it does not cover. Article 90 outlines these boundaries perfectly. For example, while it totally covers public and private premises, it explicitly excludes utility-owned service or transmission lines. Those fall under a completely different standard.
Okay, here's a term you're going to see constantly, the Authority Having Jurisdiction, or AHJ. In the real world, the AHJ is the ultimate decision-maker on the job site. They're the inspectors or agencies interpreting the rules, granting special permissions, and ultimately deciding if your installation is actually approved. When the code leaves a little room for interpretation, the AHJ has the final say.
Moving right along into Chapter 1. And listen, this is massive for your test prep. In the 2023 update, the NEC Style Manual masterfully moved all definitions alphabetically into Article 100. Previously, definitions were scattered all over different sections, which honestly caused massive confusion. Now, it's your ultimate consolidated test prep dictionary. And over the course of this explainer series, we are going to cover these comprehensively to make sure you have every single one locked down. Let's run a quick simulated exam question. Imagine you're on a job. You've got a locked panel board that requires a key to open. Across the site, you have a junction box tucked inside a light pole base that requires a screwdriver to open. According to the NEC, which one of these is legally considered readily accessible? Take a second and think about it.
Now, what's really interesting about this is the precise legal distinction the NEC makes. Believe it or not, the exam answer is the locked panel board. A locked panel board is readily accessible because the code explicitly states that a key is not considered a tool. However, the moment you have to bust out a screwdriver to take off a panel or resort to grabbing a portable ladder to reach a disconnect switch, it completely loses its readily status.
Building on that, let's just look at the word accessible as it applies to wiring methods. If you've got wiring that is physically blocked by plumbing pipes, HVAC ductwork, or other mechanical systems, the AHJ will absolutely not consider it accessible. Why? Well, because you should never have to practically dismantle the building's structural finish or major systems just to reach a junction box.
Next up is insight from. This means equipment must be visible and not more than 50 feet away. The why it matters anchor here is pure safety. When you cut power at a disconnect to work on a heavy machine, you must be able to visually confirm that absolutely no one is walking up to turn that disconnect back on from across the factory floor while your hands are literally in the gears. Here's a really tricky nuance for the exam regarding transformers. Notice how this new definition deliberately avoids saying a transformer must change voltage. That's because some isolation transformers are simply there to filter out electrical noise without altering the nominal voltages at all. So definitely don't let a trick question catch you assuming all transformers change voltage.
All right, let's shift gears and look at some of the newest definitions that have been recently updated or added. Code panels constantly update these to reflect modern technology and settle common field disputes, which makes them highly likely to pop up on your upcoming certification exams.
Take the subtle but super vital difference between a countertop and a work surface. The code actually distinguishes them based on liquid spillage. A work surface, like a workbench in a dry garage, expects much lower liquid spillage than your typical kitchen countertop. And this distinction legally dictates exactly where you are allowed to place your receptacles, keeping them completely safe from accidental coffee or water spills. Here's another recent addition, the feeder assembly. Why does this matter in the field? Well, officially classifying the heavy cord connecting an RV to its power pedestal as a feeder rather than a branch circuit is a real game changer.
It completely prevents the frustrating unwanted tripping of GFCIs that used to happen when the normal minor leakage currents from multiple appliances inside the RV added together at the source.
Next, we really need to clearly differentiate servicing from reconditioning. Servicing is just your basic upkeep, routine maintenance, or swapping out a worn part with an identical replacement to ensure operational performance. Reconditioning, on the other hand, is a major overhaul. That requires a much stricter set of evaluations, approvals, and often recertifications.
And this brilliantly illustrates how the code is adapting to modern technology. I'm talking about the Energy Management System, or EMS. These are becoming incredibly common. As solar power, battery storage, and digital load management become the standard, understanding what an EMS is and exactly how it dictates load calculations will be a major part of the 2026 code structure and your future career.
Okay, let's transition over to Article 110. If Article 100 is the vocabulary, Article 110 is where that vocabulary gets put to work. These are the foundational rules dictating the physical execution of electrical installations to protect workers and equipment.
A prime example is Section 110.16 regarding arc flash hazard markings. Specific, highly detailed labels absolutely must be field or factory applied to service and feeder-supplied equipment. And this isn't just bureaucracy. It ensures that when a qualified person walks up to a panel board or switchgear, they know exactly what level of personal protective equipment, PPE, they need to wear to actually survive an arc flash.
Moving on to Section 110.26, which is one of the most strictly enforced sections of the entire NEC. It mandates very specific clearance volumes, depth, width, and height around equipment. And let's be clear, this space isn't for storage. It exists strictly to prevent workers from being trapped, pinned, or shocked during energized maintenance.
When calculating working space depth, the requirements increase based on two things: the voltage to ground and what is physically behind the worker. For instance, if a worker is facing live parts of a 480-volt panel and there's a concrete wall, which is considered a grounded part directly behind them, the required depth of that working space jumps up. Makes sense, right? The higher the risk, the more room you literally need to pull back if something goes wrong.
Now imagine looking at an industrial control panel with its heavy doors swung wide open. This highlights a critical, life-saving egress rule. If a worker is inspecting that enclosure while it's energized and a catastrophic arc flash occurs, they need to get back and get back fast. Those open equipment doors absolutely cannot act as a barricade that traps them in the working space.
So, the crucial point is really hammering home these exact measurements for the exam. Your egress path must never be impeded. Even with panel doors open, the escape path cannot be reduced to less than 24 inches wide and 6.5 feet high. Furthermore, the floor in that working space can't be a tripping hazard. It must be kept clear, level, and as flat as practically possible.
Well, that brings us to the end of Part 1. Huge congratulations. By mastering the core of Chapter 1, you have just laid a rock-solid foundation for the rest of the codebook and given yourself a massive leg up on your certification prep. But we are just getting started. As promised, we're covering every single consolidated definition in Article 100, and that continues right into our next installment.
But before we go, I want to leave you with the final provocative exam question to chew on. As you walk onto a modern job site, if you encounter a fault-managed system that actually verifies the presence and correct operation of devices before it allows power to exceed Class 2 limits, what newly defined class circuit are you looking at? Think about it, and we'll reveal the answer and dive even deeper into the Article 100 dictionary in Part 2 of this Explainer series. See you then.